Completing the square. Our objective is to solve quadratic equations by completing the square. Who uses this? Landscapers can solve quadratic equations to find dimensions of patios. In the previous lesson, you solved quadratic equations by isolating x squared and then using square roots. This method works if the quadratic equation, when written in standard form, is a perfect square. So today, we're going to work on making it a perfect square. To do that, we complete the square. So, to complete the square of x squared plus bx, we're simply going to add the quantity b divided by 2 squared to the expression. This will form a perfect square trinomial. For example, we have our b value is 6, so we're going to do 6 divided by 2 squared, which is 9. This trinomial is a perfect square trinomial, so we can take the square root of x squared and the square root of 9, and then we take our addition sign from our b value and place it in the middle. That quantity will then be squared. Let's look at another example. So we have our b value is 10, so 10 divided by 2 is 5. 5 squared is 25. So to complete the square, we're gonna add in a 25. Take a moment and try these next two on your own. When you return to the video, the answer will be revealed for both below. And there you have it. Just for practice, the directions didn't ask us to do this, but for practice, let's simplify this. So we're going to factor, and we end up with x plus 6 squared. In this case, we're going to have x minus 9 divided by 2. That quantity squared. Solving a quadratic equation by completing the square. Step 1. Write the equation in the form x squared plus bx equals c. We want this c to the other side because we're going to get a new c value that we're going to add to both sides of the equation. Because remember, whatever you do to one side, you have to do to the other. Figure out what b divided by 2 squared is. And then you're going to add that value to both sides of the equation. In the previous examples, you were simply just completing the square. You weren't actually working to solve, so you didn't have another side of the equation to add something to. Then we're going to factor that perfect square trinomial. We practiced that a little bit in those last two examples. Then we're going to take the square root of both sides, and then we're going to write two equations using both the positive and negative square root, and then solve each. This might be easier if we look at an example. So we're going to solve by completing the square. We have x squared plus 14x equals 15. Notice how at this point the c value is already on the other side. We don't have to force it to do so. So step 1 is all set. Step 2, we want to find b divided by 2 squared. So our b value is 14. So we're going to do 14 divided by 2 squared, which gives us 49. Step 3, we want to add this 49 to both sides. I like to think of this as our new c value. So we add the 49 to both sides. And now we can simplify the right-hand side and factor the left-hand side. So we have this quantity squared. To get rid of the square, we want to take the square root of both sides. Remember, when you take the square root, you end up with plus or minus, because you didn't know whether or not it was a positive or a negative. And now we're going to write out our two separate equations, because one deals with a positive 8 and one deals with a negative 8. However, we have one last thing to do. We want to solve for x. That way we can solve by completing the square. So we solve for x, and we end up with x equals 1, or x equals negative 15. Let's try another one. Alright, so we're going to want to rewrite this, so that way we have x squared minus 2x equals, and then if we move the negative 2 to the other side, it ends up being a positive 2. Step 2, we want to find our new c value here. So we're going to do negative 2 divided by 2, and then square it, which gives us 1. So we're going to add 1 to both sides. So we have x squared minus 2x plus 1 equals 2 plus 1. Next step, we can factor the left-hand side and simplify the right. So we end up with x minus 1, that quantity squared, equals 3. So now we take the square root of both sides. So we end up with x minus 1 equals plus or minus the square root of 3. And now we can rewrite. I'm going to move it up to the side of the screen so it's easier to see. So now we have x minus 1 equals a positive square root of 3, and x minus 1 equals a negative square root of 3. And then we're going to solve for x. So we're going to add 1 to both sides in each equation here. So we end up with x equals 1 plus the square root of 3, and x equals 1 minus the square root of 3. And that ends that problem. Take a moment and pause the video and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. Now let's try solving ax squared plus bx equals c by completing the square. So now we have an a value in front that isn't a 1. So step 1 would be to make sure it's just a 1. So we have a negative 2 in front of this example, so we're going to divide everything by negative 2. So now you're left with x squared minus 6x plus 10 equals 0. From here, it should look familiar. We move the 10 to the other side, and now we're going to find our new c value. So b divided by 2 squared gives us 9. So we're going to add 9 to both sides of our equation, and then we're going to factor the left and simplify the right. So now we have x minus 3, that quantity squared, equals negative 1. However, you can't take the square root of a negative number and have a real solution. So you can stop there. There are no real solutions. So the only new piece when dealing with an a value that's not 1 is to divide everything by that a value to get rid of it. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. Now let's try a problem-solving application. A landscaper is designing a rectangular brick patio. She has enough bricks to cover 144 square feet. She wants the length of the patio to be 10 feet greater than the width. What dimensions should she use for the patio? Round to the nearest hundredth of a foot. So we have length times width equals our area. And in this case, so our length is going to be x plus 10, and our width is going to be this x. It's going to equal our area, which is 144 feet. So now let's simplify. So we end up with x squared plus 10x equals 144. So we want our new c value, so we're going to take our 10, divide that by 2, and square it. So we end up with 25. So we want to add 25 to both sides. So we're going to have x squared plus 10x plus 25 equals 169. We're going to factor this left-hand side. So we have x plus 5, that quantity squared, equals 165. And in case you're wondering where the 165 came from, 25 and 144 are added together to make 169. So now we're going to take the square root of both sides. So we have x plus 5 equals plus or minus the square root of 169. And the square root of 169 is 13. So we have x plus 5 equals plus or minus 13. So we write out both of our equations here. So we have x plus 5 equals a positive 13, and x plus 5 equals a negative 13. So we solve for x, and we end up with x equals 8, or x equals negative 18. Negative numbers, however, for what we're trying to do, don't work. You can't have negative feet for a side length. So this one doesn't make sense. Therefore, x must be 8. So your width is 8, and then your length is going to be 10 plus 8, so 18. And there would be the dimensions rounded to the nearest hundredth of a foot. That also concludes our video lesson on completing the square.